it. This and suppress that because I know the audio is working. Let's see. Done. We got a few more that showed up. Get this through that. Okay. This. All right. So I'll check attendance again around the 15-minute mark. So in like about 9 minutes. Start the broadcast. Come on. Okay. All right. We're gonna kind of work with this. So let's go view single page. Okay. I'll just kind of like do my analysis, and I'm looking for my confirmation that this stuff is working. Let's see. All right, gentlemen, it's looking good though. I can see the image. Let's see. So welcome. We are at the top of week 3, right? So we are a little bit behind schedule. I just checked the schedule, and it looks like we're supposed to be wrapping up chapter 1 this week, which we're not really going to do. So what we're going to do is I'm going to do the best that I can to do about 2 sections a day, give or take. Thank you. So, you know, we'll do the best that we can in that light. Okay. So let's just kind of hop into it for today. So we're continuing chapter 1 on differentiation. Again, the main takeaway of differentiation is that the derivative is the slope of the tangent line at a point, right? A tangent line, all it is, if you have a curve and you have a line that grazes the curve, it doesn't cross like a 90, it grazes the curve, like, right, at a point. And so that's called a tangent line. And so the derivative is the slope of that tangent line.
I have a question.
Yes.
How you doing? My name is Amari, and so this just relating to the class and as a whole. I had you for algebra 2. And in the class, like we would go over homework problems and like you have recorded. What'd you say?
No, I'm sorry. That's the goal. But just because we're so far behind, we don't have that luxury, right?
Oh, we're behind.
Yeah, like in college algebra, it was set for like basically 1 section per week. So we did have the luxury of going through the homework. Here, we're behind. We really should be doing 2 sections a day. And that's lecture, and that's without touching the homework. Go ahead. Okay. Yeah. Now, I mean, I could launch into the homework, but I'd rather not do that without context, even though I know you guys are like supposed to watch the pre-recorded lectures on your own. Do you have a question from the homework? We can like take some time to look at some homework questions. If you have some in particular, and again, if we do get up to speed, then I can kind of start going into the homework. But, you know, right now we barely have enough time together to kind of touch on these different topics. Right. So like my goal for today, we only meet for like 50 minutes. Right. And so that's only like 20-25 minutes, you know, per section that we can devote. So most of the learning, that's why I made those pre-recorded lectures, because we have to take advantage of that time. We just don't have enough time when we're meeting together to kind of go through that. But I would go through that if I could. But I just feel like it's not a good idea without introducing some concepts, you know, without touching on some concepts. So, all right. Well, you know, yeah, you good. So, question too, Professor. Go ahead. Yes.
So I'm kind of still trying to fill out the framework for this class, because one thing I've noticed is like when I get to the homework, it feels like I'm more so trying to use the view examples on the homework to teach me, and then do the assignment, and then we meet after. So I'm kind of trying to understand, is our class time, are we devoting that to teaching the lesson and then of course doing the homework that corresponds to it, or how so?
Like we already did our homework on 1.3.
Y'all want to? We can go to the next section.
No. I'd prefer to understand like the part of the difference quotient and things like that, because I think that was an area that tripped me up personally in last night's assignments, and I didn't finish them all.
Yeah, let me take some time to try to introduce this topic. Like, it is better to go sequentially, right? If you get ahead, that's cool. But let's do the best we can to try to at least introduce the concepts. There will be a chance. I mean, honestly, I'm open to kind of hanging out after class. Like, I'm not going to be doing anything. So, like, if when the time is up, if you guys want to do a homework session, we can do it. I'm totally open to that. Okay, but let's try to maximize at least this time, since I know that everybody's free. The real intent of class time for me was for class time to be a study session and a Q&A. So that's why I'm open to, like, we can do some questions now, but I'd rather just introduce these concepts. And then when we do let out, if anybody wants to stay, I'm willing to stay, and we can just devote that time specifically to whatever homework questions you want to ask, and we can kind of go back and forth until we get some resolve. Let's kind of move forward. So here, let me see. I'll give it a few more minutes. I'll check attendance again. So let's introduce this concept of section 1.3 with average rates of change, right? So average rate of change, the simplified explanation for that for me, whenever I see average rate of change, I just think slope, right? It's just the slope between 2 points. And these are different, like, articulations and applications of slope. That's all it is, all right? So the objectives here, we want to compute an average rate of change, which is essentially just the slope. You're going to see it expressed different ways, but it's essentially the slope between 2 points. And then find a simplified difference quotient. We'll talk about that, but again, difference quotient again. And I know one student made use of the Ask My Instructor. I did make a video response. It should be there. So that's why it's important to be subscribed to my YouTube with the notifications turned on. Because the student did ask a question about difference quotient, and I made a video response that was earlier today. So we have this definition: as x approaches a, the limit of f of x is L, written in this form. Again, the limit as x approaches a of this function is going to be L, right? If all values of f of x are close to L for values of x that are sufficiently close to but not equal to a, right? So what this is saying is that if you have a curve and you have some a, which is on the x-axis, right? As our x's get closer and closer to that a from the left and the right, our y value is getting closer and closer to L. That's what this limit definition is saying, okay? So then now, if we look at the average rate of change, as x changes, so if we consider the xy plane and we consider an x1 and an x2, right? Two different x values. I mean, this is basically the slope, the slope between 2 points. Rise over run, change in y over change in x. That's all that this is saying, okay? So average rate of change is just the slope. Difference quotient is essentially just the slope as well. Let me put it in context for you when it comes up. So then if we look at a graph, now we have the slope, right? Change in y over change in x, y2 minus y1, that's from college algebra. But we can express y2 as f of x2 and f of x1. All right, so the slope can be expressed in this form: f of x2 minus f of x1. Again, that's just the change in y over the change in x, which is both the average rate of change and the slope of the line between P and Q. Okay, so the line through P and Q is called the secant line. So we have our curve, right? And we have some point P and some point Q. So when you draw a line through 2 points on the curve and this line crosses the curve more than once, that's what we mean by a secant line, all right? So then what we're gonna see is, now, keeping in context, keep it in the back of your mind that the derivative is the slope of the tangent line at a point. Based on this image, right, we're gonna explore what happens to the slope of this secant line as Q moves closer and closer and closer to P. That's the main gist of the differentiation, right? And the applications of the derivative are like vast and numerous. It has so many different applications and implications. But for right now, the derivative is the slope of the tangent line. Remember, so right here we have displayed a secant line. A tangent line, if this Q gets closer and closer and closer to P, the limit, now you take the limit as Q approaches P. Once Q is essentially right on top of P, now we're talking about a tangent line. And so, this difference quotient and, all this discussion is trying to approximate or get a better and better approximation for the slope of the tangent line at a point, right? Hopefully that made sense. If I need to say that again, just say so. I can repeat it. Maybe not the same way, but it'll be the same concept. All right, okay, so that's essentially what we're going to be doing. So in this example, for this y equals x squared, average rate of change, right? In other words, again, for our concept, whenever you see average rate of change, just think slope, right? So basically they're saying find the slope as x goes from 1 to 3. So then, you use your slope formula. You let when x is 1, you have a corresponding y. When x is 3, you have a corresponding y. And then you know how to find the slope between 2 points. I think I'm going to leave that as an exercise, right? The main takeaway from this example is that you're basically finding the slope between 2 points. They give you 2 different x values. You find each corresponding y value and then put it into the slope formula. Change in y over change in x. I'm going to leave that as an exercise because I think you guys can handle that. And so we have a typed up version of that. If we need to see those details, we can always go back. But essentially the idea, the gist there is find the slope, right? I don't want to spend time on that just yet. Okay. Again, I usually leave the quick checks as an exercise for you guys. Okay. So again, average rate of change is the slope. We're going to let that be. Let's look at this definition. Yes.
I have a quick question once again.
You're good.
I'm sorry. There's also people waiting in the waiting room as well. But I wanted to ask something regarding this again. I like you were saying before, like I'm kind of confused about the structure of the class because these topics that we're learning right now were due for homework over the weekend. So
you there? Hello?
Hello?
Yeah. Okay. Yeah. Can you hear me?
Yes, I can. You hear me?
Yeah.
Did you hear my question? Or like
I heard you were confused about the structure, but then that's all I heard.
Yeah, so I was saying, if you can hear me clearly now, I was gonna say like, the like way the class is structured, like you're teaching this lesson to us today, but we had to do for homework over the weekend. So I'm kind of confused. Like, are we gonna go? Do you kind of expect us to do the homework on our own, and then you teach the topic?
It's okay that you're ahead. Like that's totally okay.
But the thing is, I don't want to be ahead because
I guess that's I'm a second that because I guess this information would have been a little more useful yesterday.
Yeah, because like there's no like what's the point? We already had to do it on our own.
I didn't finish my assignment yesterday, and I was hoping that we could actually have a slight extension because I'm kind of confused. Like I did the first assignment, and then the second one I was just completely lost because they stack on top.
Remember, hey, with all assignments, we get unlimited attempts, and there's only a 10% late penalty. Homework is it's a small portion of your grade. It's not going to affect you that much. So it is a good idea to be ahead because it's a lot of information. And like, if I increase the rhythm, that's going to make it worse, right? So, but the real rhythm that we need to be on is where you guys are. I'm trying to get caught up to where you guys are. It's okay to be ahead, right? And it's not gonna hurt you. Even if it was due yesterday, it's only a 10% late penalty. So if you're on track, if you're watching my pre-recorded lectures and you're on track, you're fine. Even if you submit it late, you're still fine. The main thing is that you get it. And the main thing is that you can actually perform on the exams when they come out. I want to say that exam 1 is going to become, 6 weeks, right? Yours is a little bit different. You guys have 2 exams. So we have a little bit of time. It's okay to be ahead. That's totally okay. If you're on track and it's a review at this point, it's okay. Like, it's nothing wrong with being ahead. There's nothing wrong with that.
I guess for me, it's more so I'm not really trying to accept late penalties each time when I need a little more.
It's not going to stop you. It's not going to hurt you. I promise you. Like, as long as if you're ahead and you're on time, even if you're late, as long as you can perform in the exam, because that's where your points really come from. The exams count for like almost 80% of your overall grade. The homework and quizzes, that's really just there as work to get you ready for the exams. Like you're worrying about things that really don't matter. Like, it's really going to be okay. I promise you. Like, don't worry. Even if you take a late penalty on the homework, that's like maybe 0.5% of your overall grade. Like, not even a full percent. Like, I promise you, you'll be okay. Even if you submit the homework. Like, I've had students submit all their documents, at the very last second. And I checked it. They got the credit. They walk out with like a B or an A, and they were fine. I mean, like at the very last second. So if they can do that, it's okay if you take a little bit of a hit on the homework, right? It's going to be okay, because again, the homework is not a heavy weight. The real thing is we're trying to get you ready in time for the exam. That's why it's a good idea to be ahead. You don't want to be like trying to play catch up. So now we're like eating up precious time when I could have been on to the next section by now. You see what I'm saying? It's like, it's okay. It really is designed for you to learn on your own. It really is designed for you to like get ahead, because again, we only have 50 minutes a day, twice a week, right? 100 minutes in a week together. And then the rest of that time, you're either working with your classmates or the tutors, or if we do happen to meet outside of class, then so be it. But together, we don't have a lot of time. So that's why I built it for you to, that's why I took my time and made those lectures in detail in advance, so that I'm really just trying to use this time to just try to clear stuff up. But you're really supposed to learn on your own and get ahead and then ask me questions.
All right.
I have a question. It's actually to the problem. So I'm looking at the line. It was P to Q last time. But I'm a little confused because the curve line, if we were trying to find it, like a point, find the tangent line, correct me if I'm wrong, but it wouldn't go through the line, but it would rather go like at the same slope. So yeah, so like at point P, wouldn't it be
this about tangent lines? This one is about secant, right? This is we're still building up to that tangent line discussion. We haven't gotten there yet.
Oh, okay, my fault.
We're still stuck on like the structure, right? We haven't gotten. That was like a little bit of foreshadowing. Like what's coming up. That's what we're trying to get to, right? But the main takeaway for average rate of change is just the slope between 2 points. So then what we're going to be doing is, as that second, that's what this slide is here. Yeah, I think that's where we left off, right? So we know how to find the slope between 2 points, right? That previous slide was about, exploring the slope of the secant line, the line that intersects the curve more than once, right? So now let's look at this definition 3, okay? So now we have the average rate of change of f with respect to x is also called the difference quotient, right? So the slope, remember, I know I said that in my video response to the homework. And again, the whole point is difference quotient is just another way of saying the slope, right? But what we're doing here is just a different way of saying it, but there is leading up to something, right? So before, this was the point P and this was the point Q. And remember, I was like, we're going to explore what happens as Q gets closer and closer to P. As Q gets closer and closer to P, this secant line gets closer and closer to our tangent line, right? So that's what this slide is about. So the difference quotient, instead of putting P and Q, we have our x, f of x, and now we want to consider some change, right? So as we go from x1 to x2, we want to consider some change h, right? So all we're doing to generate that x2, we're adding some change to the original x. That's the only difference with the difference quotient. It's just a different articulation of the same thing, right? So then h is we're just adding some change in x to the original x, right? That's what h is. So we have our original x, now and this x2 is generated by adding some change to the original x. Then we find the corresponding y, okay? So now we have this x and y, the original, I guess you can call it P. And now we have our second point Q, which is, all based on adding some change to x, okay? So now what we're gonna do, now we're gonna say, take the limit as this change gets smaller and smaller as this change goes to 0, right? So we started with some x here, we do some change, we get a second x, right? We added some change. So what we're and smaller and smaller. As that change gets smaller and smaller and smaller, this second point gets closer and closer and closer to the third point. So this is where now we put together the concept of limits with the difference quotient, right? So now we say, take the limit as h goes to 0, right? And that's the main thing of what the derivative is. Now that's the technical way that we find derivative. You're actually going to see we have so many shortcuts, so many quick ways you can just jump straight to the answers. Now, I don't want you to be intimidated by, this introduction, because this is just giving you the main structure or the backstory on how we find the derivative. Once we start getting into like the properties of the derivative, there are like all these shortcuts. You look at the equation, and we have ways to practically jump straight to the answer, and you can confirm it with this, right? Okay, so it doesn't look like we're really going to get past 1.3, but I'd rather just take my time. So I'm just going to do that. Okay, so that's the gist of this one. So again, so for this function, find the difference quotient when x is 5 and the change is 3. I'm just going to do one just in the interest of time, right? So the difference quotient, this comes out of college algebra, but basically it goes for this one, it's going to be f of x plus h minus f of x over h, right? And I just want to bring this to your attention. If we look at this one, if we look at this guy here, right? We had our x, we had our f of x. We had our x2 with the corresponding y, right? So then if we want the slope, we would say y2 minus y1, right? You saw me just write that, over x2 minus x1, right? When we do x2 minus x1, our x's cancel and we're just left with h, right? So again, the difference quotient is really just another way of articulating slope. So this guy here is really just articulating the slope. Okay. So now the recommendation is to find each component, okay? So we have f of x is x squared. Let's go ahead and find f of x plus h, right? So then f of x plus h, like, I don't really want you guys, like, don't make this more challenging. It is challenging, I'm not gonna lie. It's challenging, but don't overcomplicate it. If I'm telling you that the late penalty, I made it minimal on purpose because I don't want you to rush. I'm trying to minimize stress. I don't want you to rush. I just want you to have a steady pace. And I don't want you stressing out because this stuff is tough. You know, it's a lot of information that we're trying to get in here. It's an ambitious schedule. If you go back and watch the recording, I said, hey, the schedule is ambitious. We're going to do the best that we can, right? I made the late penalty minimal. You can submit stuff late and still get an A. You see what I'm saying? So it's like, don't make it more stressful than it already is. It's stressful. And what I also tried to do to minimize the workload, I did cut back on the amount of homework. I think before we had a certain amount, I think I cut them like in half because it's a lot. It is a lot. So it shouldn't take you that long to get to the homework. Even if it's late, it's not gonna hurt you. Like, you'll be okay. It's already an extension built into the assignment. It's already built into it. You just got to trust it. Keep working, keep pushing. I think you'll be fine. Like it's gonna be okay. Okay, so then all we're doing is replacing each x with x plus h. So that means we're gonna have this guy, and that expands into this 2xh plus h squared, right? So then let's go ahead. We got this f of x plus h minus f of x, and this is what I did in my recording this morning. This is what, again, it is a good idea to be subscribed to my YouTube with your notifications turned on. So when I make these video responses, you're not like, oh, how do I do this? You're like, wait a minute, he made a video on that. Let me watch it, right? Just aware. You don't have to watch it on the spot, just so you can be aware, right? So if I said f of x plus h minus f of x, you should notice some terms canceled. This guy is canceled by this, okay? So then the final thing, the final step, let me see, I see the time. So if we take that result, which is going to be this 2xh plus h squared, right? We can factor out a h from everything on top. We're left with 2x plus h over h, right? And so then these guys cancel, right? Now with this part, there's still one more piece that we need that we haven't talked about yet. For right now, we're stopping here. The additional part would be we would take the limit as h goes to 0, right? That just hasn't come up yet, right? Because then once we take the limit as h goes to 0, then we'll have the complete concept of this introduction of how to find the derivative, right? Okay, so we got 2x plus h. I'm just going to do the one. Oh, okay. So then x is 5 and h is 3. So then if x is 5, 5 times 2 is 10, plus 3 is 13. Copy that. Okay, that's good. That's what I wanted. But yeah, you just got to breathe. Like, it's going to be okay. Like, it's okay. The main thing is, as long as you're getting yourself submitted, if there's anything I can do to help you, I will. I'm not gonna slight you or anything. I'm not going to be hard on you. If we can get you in there, we're going to get you in there. You see the 13 there. Okay, they did it different. That's fine. What they did was fine. They did theirs a little bit different. They went on and plugged it in from the rip, but the way I did it was closer to how we're going to be doing it going forward, right? Because this one was just evaluated, because they gave us the 5 and the X and the H and everything, but it's fine. And it doesn't hurt to see a different way of doing things. And again, my way is not always the best way. I'm just showing you that it's possible. I do try to offer the most efficient, but sometimes, I'm not privy to it.
I have a question.
Yeah,
Go
me
ahead.
too.
Can you explain why when H approaches 0 or when H is 0, that's the derivative? Like just a quick 30-second.
Right here, right on this slide, we said H is some change in X. So this line that's shown is a secant line. The derivative is concerned with the tangent line.
Right.
So if we try to jump straight to the tangent line, it's kind of hard to get an exact, right? Because if you manually draw the tangent line, it's hard to get it exact. Let me show you what I mean. So like if we try to draw a tangent line, we might have something like this, but then we could also kind of have something that looks like that, even though it's not exact. It's like you can't manually draw. So to get the exact tangent line is kind of difficult. So we use this limit approximation as H gets closer, as H gets smaller and smaller and smaller, as H tends to 0, it gives us a better and better and better approximation of the tangent line. So we're using the slope of the secant to get a better and better approximation of the slope of the tangent.
Okay.
That's the gist of it.
That makes sense.
Yeah. And it's, to me, it's still even better that you guys are ahead. So that way, when I talk about it, this isn't your first time seeing it. Could you imagine if this was your first time seeing this and I'm saying this stuff? You're going to be like, wait, what is he talking about? You're going to be floored. It's actually, you're actually doing the right thing. Like, I'd rather you be ahead. So when I talk about it, now I can clear up anything that's not clear, versus if I'm introducing it, a lot of times it intimidates the students even more versus, anyway. This one can be a little bit intense. I'm going to kind of let this one be. I can do it if you want, but for right now, I'm just going to spare you.
I more so have a question, like from the homework, I think I struggled to set the problem up. So when they would have it, like they say 8x squared minus 5x, and plugging that into, I don't understand what went into what. It was just a lot of numbers everywhere.
Yeah, it is like that. That's where you make use of the Ask My Instructor. I know at least one student asked it. I did reply with my.
That was me. I was yeah.
And so hopefully it because I did it in the 10 minutes before my earlier class. Yeah, I mean, Okay. Actually, I do kind of want to go ahead and move into the next section. Okay, let me think. Let me go back. So let's go ahead and just take some time to go touch on the next one. Let me see. But this is good. I'm trying to keep a steady pace, but I don't want to rush. Because let's see. Let's move this one here. And I just have to remember to share those notes. Matter of fact, let me go ahead and share these notes with you guys. So this one, or could I just add it? No. Yeah, maybe I can just add it. No, that's fine. Let me share, send it to Box. The right folder, come on. 2023, calculus, notes. I should change that name. This is fine. This is fine right there. Send a Box. Okay. So what you saw me writing before, I'm making a copy available, and we're gonna go ahead and take some time on the next section. Right here. This section is differentiation using limits of different quotients. Okay, so this is that part that I was talking about where we take the limit as H tends to 0. That's what this is talking about. Let me do my title. Let me see. This is week 3. Here, let me just do it like this. Here it is. Edit. So this is week 3, Monday at 6 p.m. This is 1.4. This is differentiation using limits. I'm just going to abbreviate it like that. This is calculus Business Spring 2023. Okay, that's good. I'm gonna go with that. Let's hit done. All right, so we got a solid 15 minutes. We'll do what we can in 15 minutes, all right? But again, this is why I made my pre-recorded lectures. Now, if you guys want to hang out after class, I'm totally available. You know, we can take some time and go through whatever homework questions, because I do acknowledge that we don't have a lot of time together and I don't want to rush. I don't want to rush you. I'm trying to build this where you can people can go at their own rhythm and not feel rushed. But if you're ahead, that's actually a good thing. Section 1.5, differentiation using limits of difference quotients, right? So in that last section, we saw some examples with the difference quotient, right? The difference quotient is just the slope between 2 points. It's just a different way of expressing it. Instead of saying x1 and x2, x2 is generated by adding some change to x1, and we find the corresponding y's, find the slope, right? So now what we want to do, we want to say, okay, now as that change gets smaller and smaller and smaller, that forces that second point to get closer and closer and closer to the first. That gives us a better and better approximation. We're using the slope of the secant line to get a better and better approximation of the slope of the tangent line. Cool, stop, thank you. Okay, so hopefully that's starting to come together, all right? So the objectives here, we want to find the derivatives and values of derivatives and find equations of tangent lines, right? Before we were discussing secant, let that change go to 0 to get a better and better approximation of the tangent. Let's back up, it always does this right here. Let's try that again. Let me check on you guys at Zoom. Let me see, do we have any people? Cool, that looks good. Let me check the chat. I know I got a little bit heated there, but it's all good. Take a little on the homework, a little hit. Look, I mean, that's what it is. Like, I don't know what more to tell you. Like, I don't know. I told you, like, it is an ambitious schedule. It's ambitious. The goal is to get to the end of chapter 4, because idealistically, we definitely need to talk about integration, but we can't skip stuff. And it's a lot. It's a lot. So most of the learning is on your own. We meet to try to clear stuff up. That's the structure, right? But most of the learning is on your own. Together with the tutors, we do what we can together in class, and I'm willing to meet outside of class. After class, I'm willing to, you know, it just has to be requested. So we have this definition. It says this, thank you. The slope of the tangent line. So we're starting with our original point, you know, x with the corresponding y. Remember, we said that h is some change in x. H is some change in x, right? So now we're going to take the difference quotient, but now we're going to let that change go to 0. So as that change gets smaller and smaller and smaller, this second point gets closer and closer and closer to the third point. So then what's happening is our secant line, the slope of our secant line is giving us a better and better and better approximation to the slope of the tangent line, right? So and once we take the limit, that's about the best approximation that we can get for the slope of the tangent line at a point. If you try to draw a tangent line mechanically, you know, this is a tangent line, this is a tangent line, and they're close, right? It is not exact if you try to do it manually. So this limit definition is the mathematician's attempt at approximating the slope of the tangent line at a point. Hopefully that makes sense, okay? So for a function, its derivative at x is f prime, which is defined by the limit as h tends to 0 of the difference quotient. Okay, the derivative, which is the slope of the tangent line, is defined by the limit as h tends to 0 of the difference quotient. Again, the difference quotient is just the slope between 2 points, where that second point is generated by some change in x. This provided the limit exists. So if the limit exists, we define it like this, okay? If the derivative exists, then we say that f is differentiable at x, okay? All right, let's keep going. So for this function, find f prime, then find f prime of 3 and f prime of 4. I so want to jump into the shortcut, but look, we need to see an application of the limit definition of derivative, right? We're going to do the best we can with this, right? Don't be intimidated by it. Just know that it's, to me, this is my opinion, it's easier on the other side of this. Like the shortcuts, because I already know the answer looking at this, right? But let's since we've talked about the limit definition, let's see a presentation on the limit definition of derivative, right? So now, if the derivative exists, it should be the limit as h tends to 0 of the difference quotient. So that's going to be f of x plus h minus f of x all over h, right? So then it's a good idea. Let's go ahead and find each part first. Let's start with f of x plus h. Okay. So then, okay, so I think we did something like this earlier. Basically, you're going to square. If you square that binomial, you get x squared plus 2xh plus h squared. Okay. I just replace the x with x plus h. FOIL, you get this. Okay. We got f of x. So let's go ahead and find f of x plus h minus f of x. So then if we subtract f of x from the above, the x squareds cancel. This is a repeat of what we had before. We did this just a moment ago, right? So that's our numerator. So now if we want to look at f of x plus h minus f of x over h, basically, you know, we can factor out an h from the numerator. We're going to have h times 2x plus h, and on bottom we're going to have h. If anything is not clear, just stop me. You know, okay. So then this is equal to 2x plus h, right? So now I'm just going to keep working over here. Let's take the limit as h goes to 0. Now we're applying those limit techniques that we talked about previous week, right? So now if we take the limit as h goes to 0 of, I'm gonna just do this guy, 2x plus h. All right, we're taking the limit of that. So in this case, you can just substitute 0 for h and you get 2x, right? So then our claim is that f prime of x equals 2x, okay? All right. So now that we found f prime, now we just evaluate at those 2x values. So then what we're saying is that the slope of the tangent line of this function when x is 3 is going to be what? 6. 2 times 3 is 6. So if you looked at this curve,
It's actually a -3.
-3. Okay, thank you. -6, right? Yeah, I definitely am human. You know, I acknowledge I definitely made mistakes. Right? I have perfect imperfections. Right? So if we were to look at this curve at the parabola, you go to when x is -3. If you draw a diagonal line with a slope of -6, right? Actually, we have the slope. We still would have to find the like x-intercept to get the equation. We're going to do all of that, but graph the line so you can see. You'll be able to see that this indeed is describing the slope of the tangent line when x is equal to -6. That's actually coming up. Let's go ahead and look at f prime of 4. If we plug in 4 times 2 is 8. All right, so this is the slope. All right, so we got this result and we got this result, those 3. Okay.
So wait, quick question. So are we saying that a faster way to do it, rather than trying to like have these large equations and plug x and h in or whatever into those, we could just break it all the way down to like 2x plus h and then plug them in there?
That's not the shortcut. We haven't gotten to the shortcut yet. When in this form, I just like to break it down into parts. Instead of writing, like you say, instead of writing that long equation, because this is a game of organization. It is very easy to get lost when you write those long equations. I'd rather, okay, let me focus on this guy first. You got the answer there. Okay. Then I was like, let me focus on this guy. You got that answer right here. I was like, okay. Then let me focus on this guy. You got that result right here. I was like, okay. Then now it's easier for me to do the whole thing. I got this result. So that's not the shortcut. That's just an organization technique. That's just me trying to be organized so I don't lose track of stuff. Because this is a game of organization. It's very easy to get lost. So it is important to like, you know, space things out, declutter. You want to have as clean a space as possible, write things big, neat, and organized, try to show your details, because this is a game of organization. The more organized you can be, the easier it'll be to process the stuff. And here's a type version of what we did. Now, I think they kept everything together, you know, and that's okay too. All right, and I think they get the same thing. You can see the derivative there at the bottom, and then those results. That was good. Okay, let me see. We're doing pretty good. I know this one is intense because of that cubed. I think I'm going to bypass it for now. I'm gonna leave it as an exercise. Let me just see what else we got. Because that one, I mean, we can do it, but it's not really different. It's just a little bit more intense because of the cube. Let's try this one. So for this function, okay, this one. Yeah, I might need some space. F prime. Okay, let's do it. Let's see. Let's start with, so that we're actually find a derivative. So we have, let's go here. We have f of x equals 3 over x. I probably would have been better off doing the x cubed one, but that's okay. Let me cut this guy. Cut. And I'm here. Let me add a page. And let's go to template. We want this orientation just to be consistent. That's fine. Okay. Let's go ahead and add another page. And let me do the view as seamless. Okay. All right, cool. All right. What's the time? All right, paste. So let's find f prime, right? And again, we're going to go ahead and do the limit definition. This one does have a trick in there. We'll just catch it as it arises. So we're going to use f prime is going to be the limit as h tends to 0 of the difference quotient. So that's f of x plus h minus f of x all over h, right? So let's do part by part. This one does get a little intense, so we just have to do the best we can. Let's start with f of x plus h, okay? So then if we replace the x with x plus h, we'll get this, right? And I don't think we can break that down any further. So then let's look at f of x plus h minus f of x, okay? So then that's going to be this guy minus this guy, okay? Let's get a common denominator. So common denominator, we're going to multiply this one by 1 in the form of x over x. We're going to multiply this one by 1 in the form of x plus h over x plus h. Okay, hopefully this is okay. Let's keep going. So then on the left on top, we get 3x. And on the right, if we distribute a -3, we get -3x minus 3h. Okay, you should notice something canceling. And on bottom, we're going to leave it as x times x plus h. I'm going to leave that spread out for now. Okay, we should notice that these guys cancel, right? And I think that's as far as we can kind of take that part. X times x plus h under this -3h, okay? So then, now let's go ahead and, no, we need to divide by h, right? So we need to do f of x plus h minus f of x over h, right? So basically, if we divide this fraction by h, that's the same as multiplying by 1 over h. Let me do that one more time. If we divide this guy by h, that's the same as multiplying by 1 over h. So I'm going to multiply by 1 over h. So then on bottom, we're going to have h times this x times x plus h. And on top, we're going to have this -3h, right? So whenever you're doing this technique, this limit definition of the derivative, you're on track when you get to a point where you can successfully and correctly cancel these h's like that. When those h's cancel, then 9 times out of 10 you're on track, right? So now that simplifies, because that's kind of the goal, is to get those h's to cancel. Because if they don't cancel and you try to take the limit as h tends to 0, now we're dealing with a 0 in the denominator and we can't proceed, right? We got to do something different. But now that we got our h's to cancel, and so we got this is simplified down to x times x plus h under -3. Now we're ready to take the limit as h tends to 0. Okay. And again, all the stuff that you see me writing, you're going to get a copy. I'm watching the clock. We got the limit as h tends to 0. We could say of f of x plus h minus f of x all over h. Okay. So this is going to be, essentially, you can just replace the h with 0. We're going to have x. I'm going to write it out. Again, we replace the h with 0 there. under -3, okay? So then ultimately we get -3 over x squared. That's our f prime. That's our derivative. And I'll just put that here. Okay. So then the question asked us, it asks us to find f prime of 2 and then find an equation of the line, right? So the derivative gives us the slope, right? The derivative gives us the slope. They want us to find the equation of the line. So once we have the slope and a point, we can find the equation of the line. So then it says find f prime of 2. So then I guess this is part B. F prime of 2 is going to be what? -3 over 2 squared. So -3 over 4. So then the equation of the line, I'm going to abbreviate it as y tangent. I know that's probably not proper notation or whatever, but so we're going to use y equals mx plus b, okay? This is going to be our slope. We found the slope. Okay, another thing. So when x is 2, we need the corresponding y from the original. So when you plug in 2, you get 3/2, okay? So then we got our slope. We also have the point 2, 3/2. So that's the x with the corresponding y from the original. So then now we have a slope and a point. Now we could use point slope. I think some students showed me you could just actually plug it directly into y equals mx plus b. I checked it, I confirmed it. It actually works, all right? So I prefer to just go y equals mx plus b. So then let's plug in our components. So our slope is a -3/4. Our x is 2. We're trying to solve for the y-intercept. And the corresponding y is 3/2. We have one equation, one unknown. We can solve for b. That's 3/2. So you add in 3/2 to both sides. B equals 3. It's what? 3 and 3 is 6 over 2. It's 3. So the y-intercept should be 3. So then our equation should be y equals our slope -3/4 x plus 3. Okay, now we can actually check this. Our claim is that this is the equation of the tangent line when x is 2 for the original, right? Let's confirm this, right? Let's see how can we confirm this. Okay, so I want to open up my trusty dusty Rusty. Let me see if it'll show. Oh, let's see. Let's do a new tab. Is it not showing? Can you guys see my calculator? I don't know if you can see this. Yeesh. It looks like it's working. I'm gonna go with it. Okay, I can see it there. Okay, so the original, right? The original is, let's graph that. We're gonna go to y equals, and we're gonna put 3 over x. We get this, right? So that's gonna be the original. I want to change that so that it's just change the graph. So it's gonna be dots. So that way the asymptote is like not displayed incorrectly. But then my tangent line, I'm gonna let that one be solid. Oh, is it just not? Okay, that's fine. And the tangent line that we got was y equals a -3/4 x plus 3. Okay, so what we should see is the reciprocal function. And when x is 2, we should have a tangent line, a line that grazes the graph at a point, right? So let's see what happens. So we have our reciprocal function and x is 2, right? You see it cross. And let's do this. Let's go to stat plot. Let's go to, where's stat? Right here, edit. So we got the point 2, 3/2. Okay. Let's go to stat plot. Let's turn it on and we'll plot it as a box, right? So you can see the graph grazes or creates a tangent line at that point. So again, what the limit definition does is give us the best approximation that we can for the slope of the tangent line at the point. Okay. We can see the tangent line. It intersects at a curve, right? We can see it all there. Okay. I know it got a little heated. We just got to dust off the cobwebs. Like, it's okay. Like, it's okay. I promise you. I'm trying to be as light and gentle as possible because this stuff, it can be a little intense, right? We got a solid like 10 to 15 minutes, right? So we want to, let's keep moving. Okay, so we graphed this stuff. We confirmed everything worked. You know, so we're good to go there. So we saw this limit definition. I think they're doing the same thing that we did. I think they got the same result. You see it there, the -3 over x squared. And then for part B, the -3/4 was the slope of the tangent line. And then I think we got that same result. Okay, so this is our equation of the tangent line at x equals 2 for the original curve. Okay, just stop me if you have questions. Oh, quick check. Let me see. Did we make it? No, we're actually not that far off from the end of this guy. Okay, a few more like. So I actually made my own Morehouse ringtone. That's what you just heard. I actually made my own Morehouse garage band. Oh man, you should have heard the song too. It was like it flows. Like it was actually kind of fun. But we can talk about that another time. Okay, so where a function is not differentiable, right? So remember, the derivative, we're trying to find the slope of a tangent line, right? So could you imagine trying to draw a tangent line at a sharp corner like that, right? This is a tangent line. This is also a tangent line, right? This is a tangent line, right? So whenever there's a sharp corner or edge, you cannot find the derivative at that point. So if there's a corner, it's not differentiable. Same thing here. All of these guys are not differentiable at those sharp corners, okay? Because there's going to be infinite number of like tangent lines at that point. Same thing here, right? You know. All right, those are all tangent lines. It's not unique when this happens. So if there's a sharp corner or edge like that, you're not going to have a tangent line at that point. Okay. If a function creates a vertical tangent line, then we say it's not differentiable. All right. So if you draw the tangent and it creates a vertical line like this, we say it's not differentiable. It's not differentiable at that point. Okay. And if there's a hole or if there's a gap. All right, let me see. A function is not differentiable at a point if it's not continuous, right? So there's a hole or a gap in the function. So when x is -2, there's not a tangent line here at this guy. There's not a tangent line. Okay, so sharp corners, what was the second one? A vertical tangent line or a hole or a gap. If it's not continuous, then at those points of discontinuity, we can't find the derivative. Okay. Wow, we actually made it essentially to the end. We still have a solid 10 minutes. This is honestly when 10 minutes isn't a lot to go through the homework. I'll go ahead and attempt now. I can jump straight to a question if anybody requests it. If not, I do want to try to touch on as many questions as I can. I guess I'll start with 1-3.
Would you mind like going?
We can start wherever.
Could you go to the
open it
homework
up.
sections on 1.3 and show the different quotient like examples on there?
Yeah, let's take a look at it. Because I do acknowledge some of these questions get a little intense in that, you know, they're very meticulous. You got to follow the instructions to the T. That's why I do unlimited attempts. That's why I do a minimal late penalty on stuff, because it is a challenge. So I try to compensate that or offset that by, you know, not being so strict. You know, I'm not really trying to be strict. I'm just trying to touch on the material. I'm kind of filling the air until we can get this thing up and running. Allow. Okay. All right. So the request is from 1.3. Okay, this is fine. We at least got through 1.4 today. Today is Monday. We still have a good amount of sections, but we're okay. We'll just kind of keep going. I know we're behind. I think the request for 1.3. So let's look there. 9 questions, right? I'm gonna just start. I'll just start with number 1. Okay, we got a solid 10 minutes. Okay, so let's see. Basically, we're evaluating the function. I think I'm going to skip this one because this is not about our topic. Okay, find the simplified form of the difference quotient and then complete the table.
Yeah, I understand that one. More so,
Okay.
yeah, the difference quotient ones, yeah, but the ones that are like complex.
Just
So
tell me which one and we can talk about it.
I think try like number 4. I think 4 got a little.
Okay. Find the simplified difference quotient, right? And then complete the table. So this is kind of a repeat. I don't know if you want this one or not. Difference quotient, we can try it though.
Okay, yeah, like this one. What are we plugging into where? Let's try this one.
So the difference quotient, right? So they gave us our function. So we're going to get a copy of that. And then we need to find a simplified, we need to basically find the difference quotient, right? So let's get a copy of this guy. Take this. I want it from like here, so we can always reference it later. And again, all these things that you see me writing, I'm going to make a copy available on Blackboard at the end of class. I want to copy and delete. And let's hop over here and come on to the bottom. Let's add one more. Come on, view. Nope. That's not what I'm trying to do. You see my, it's okay. We'll start like here. And let's paste what we just pulled. Allow. Cool. Come on. All right. So we're starting with this f of x, all right? So we're basically applying the difference quotient to this f of x. And we have the difference quotient there. So let's do each part of the difference quotient, right? So the first part is, let's go ahead and find f of x plus h. So what we're doing is we're replacing each x here with x plus h, expanding and simplifying, all right? So then if we do this, we're gonna have x plus h squared minus 9 times x plus h, right? And let's expand this out. So then this is going to be x squared plus 2xh plus h squared minus 9x minus 9h, right? So we got this thing, okay? So then let's go ahead, the next part, let's do the numerator, f of x plus h minus f of x. So again, we're going to do f of x plus h minus f of x, okay? So basically what I'm going to do, I'm just going to go ahead and make a copy of this because let's copy and paste. Oh no, undo. Let me see, can I just move this? Okay, let's copy. Paste, better. Okay, and then let me kind of shrink it down just a little bit because I do kind of want to get it all on the same line. Sometimes those long equations are unavoidable, right? We're going to subtract f of x. So we need to distribute a negative into f of x. So I'm going to say minus x squared plus 9x. Again, because I said minus f of x, I distributed my negative into f of x, okay? So now I didn't need all of that. Let's get rid of what we don't need. We didn't need this. Where'd it go? Let me do this. Delete, paste, and this can go. Delete. Okay. I copied an extra part, so I'm just trying to keep it to all that we needed. We only needed that end result. Okay. So now let's see if anything cancels. This x squared cancels this guy. I think that was a 9x. This plus 9x cancels this negative 9x. Okay. So then now, idealistically, each of the remaining terms should have an h, and they do. So we're good there. So now we can go ahead and do the whole difference quotient, right? Which is going to be this f of x plus h minus f of x all over h. So I'm going to go ahead and factor out my h from the remaining terms. And that's going to leave me with 2x plus h minus 9. And on bottom, we have our h. So then it's like this. All right. So now they cancel. That's the goal, is for those guys to cancel. And so at this point, I'm watching the clock. -9. We got a solid 10 minutes. Okay. 2x plus h minus 9. Okay. So then from there, I think we can just plug them in, right? Because if x is 7 and h is 2, or okay, the 7 is consistent. You can even like make a table real quick, but that's going to be 14 minus 9, which is what, 5? So then it's 5 plus 2. 5 plus 2 is what? 7, 6, 5.1, 5.01. All right, so notice that as that h is getting smaller and smaller and smaller, this slope is getting closer and closer to 5, right? If you think in terms of limits. So let's see, let's try plugging that in and see how do we do. So we got basically 5 plus those, right? So then the difference quotient, hopefully it still lets me. We got 2x plus h minus the difference quotient, do not factor. Simplify answer. Okay, I'm going to go with settings. Turn that off. Okay. What do we say? 2x plus h minus 9. We're gonna, let's see, we'll fix it if it's not right. Okay, that's fine. Difference quotient. So then basically because the 7 was consistent, it was 5 plus those h's. So 5 plus 2 was 7 there. And then 5 plus 1 was 6. Okay, so let's do this thing. 6. Totally being temperamental. 5.1. And 5.01. Okay. Let's try to get one more in. And then we'll see what you guys are, how you guys are feeling. Oh, it must be because it's late is why I gave us that. That's fine. Like I'm not, like honestly, if you get to the point where you can like do well on my exams, we're gonna find a way to get you through. Like if you can do well on my exams and prove that you get the stuff, I'm not gonna like, it's not gonna stop you. Like we're not gonna let this stuff stop you, right? Find a simplified difference quotient for the given function. Okay, so I mean it's essentially the same thing. This is gonna have a lot of extra stuff. Let me look at the next one.
Actually, yeah, could I see this one? Because I can stay after, but I didn't understand that.
Do that one, that's fine. We got this. Let's get a copy. Let me see. We're going to take it from here. And I try to keep the label so that way if you ever look at these notes later, you know where it's coming from. That where it says question 5, 1.3.65, that means it comes from section 1.3, question 65 from the back of the text. So you can always flip, copy and delete. You can always find it. Okay. Let's go here. Let's paste. Allow. Come on. I think my device is like, I don't want to play no more. It's like it's tired. I was a little bit late. I was definitely gaming, but I got it here. I mean, it was only like a minute, so okay. It wasn't like as bad as it could have been. Okay, difference quotient, right? So find a simplified difference quotient. So difference quotient, it didn't say the derivative. The difference quotient is just going to be f of, stop. I know we got 5 minutes. We got f of x plus h minus f of x over h, right? We're plugging that, we're using that f of x in this difference quotient, right? So let's first start off with f of x plus h. So what we're doing is replacing each x with x plus h, expanding and simplifying. So we're going to have m times x plus h squared plus d times x plus h plus b. Okay. If we expand, it's going to be m times x squared plus 2xh plus h squared. That comes from FOIL. If we distribute here, and we did FOIL here, we get dx plus dh plus b. Okay, that's a b. And then we need to distribute this m. Okay. So then this is going to give us, I guess we can write mx squared plus 2mxh plus mh squared plus dx plus dh plus b. Okay, so that's f of x plus h. So now we want to consider f of, what is this? F of x plus h minus f of x. Okay. So we're basically going to say all of that minus the original. So let's just go here. Mx squared plus 2mxh plus mh squared plus dx plus dh plus b. Now minus f of x, so we need to say minus, we got to distribute our negative, mx squared minus dx minus b. Okay. All right, so let's see. Now, hopefully, I'm watching the clock. We got a solid 2 minutes. We can get some things to cancel, right? We got a negative b is canceled by this positive b. Negative dx cancels the positive dx. Negative mx squared cancels the positive mx squared. And what we're left with, 2mxh plus mh squared plus dh, right? And notice each of these terms being things that we add and subtract, they all have h. Right? That's a good omen, right? So then the next part for the simplified difference quotient, we're going to say f of x plus h minus f of x all over h. So basically we're dividing all of that by h. So let's go ahead and factor out, an h from each term, okay? And that's going to give us, it's going to give us h times 2mx plus mh plus d all over h, right? That's the goal. Now we can cancel our h's. And again, the main trick with this stuff is being neat and organized. To me, for these long equations, break them apart, do them part by part. Do the f of x plus h first, you get a result. Now go ahead and subtract f of x, be sure to distribute negative, get a result. Idealistically, at that point, you should have the orange h's like you see at the top of the screen. Factor out that h, divide by h, because that's the next part of the difference quotient. If you're able to get to this part here, that's the main part, that's the challenge to get to. Once you get to this where you can factor out the h's and cancel, you're pretty much home free from that point. Because once we cancel the h's here, we're left with 2mx plus mh plus d, okay? And I think that is it for that one, okay? It didn't ask for the limit, it just wanted the difference quotient. So let's submit that result. 2mx plus mh plus d. I see the time. We got enough time for me to submit this and check, and we can entertain questions. And again, if you guys want to, hang on, let me see, I got it here. Come on. 2mx plus mh plus d, cross our fingers. God is good all the time, right? It's no joke. But I don't want you guys worrying and stressing about this stuff. Just do the best that you can. I did unlimited attempts on these assignments on purpose. I did a minimal late penalty on purpose because I want you to take your time, but move at a steady pace and minimize your stress. This, because if you let the experience just run wild, you're gonna be stressed out, right? I'm trying to minimize that stress, right? I'm not here to stress you out. I'm here to get you through this content. So that way, when you leave this course and you go some other places and they expect you to know about integration and some of these other concepts, you'll have some level of proficiency. But I would be doing you a disservice if I don't do my best to get you through the end of chapter 4. All right, because this is the only chance that you're going to see this material. If you do anything beyond calculus, and you haven't talked about integration, that's a disservice to you. All right. Okay. Let me go ahead and make a copy of this available. I'm gonna send this to Box. Okay, that looks good. So when this bar finishes loading, you'll receive a copy of anything that you saw me writing. I loaded the first one earlier, and the second one will be there in like a few seconds. You just go to Blackboard, and it's basically in that central hub link or whatever. And where it says Box link, you can find it there. If there aren't any burning questions, we're actually going to end the session here. If anybody wants to hang out afterwards and like do more homework, we can. I'm totally game. All right. Otherwise, from one beautiful mind to another, enjoy the rest of your day, guys. Take care. You can do this. I believe in you. You wouldn't be here if you couldn't do it. And you wouldn't come across my path if you can't handle it, right? You can totally do it. Just take a deep breath and make a plan and take action. I encourage you guys to definitely work together. It's okay, right? It's really here just for you guys to be exposed to the stuff. I'm not trying to drill anything. I'm just trying to get you ready, right? Because when you leave this hollow ground of the house, it's unforgiving out there. They're not going to care. They're going to do everything like in person and paper, be hard on you. If you're late, tough problem. They are not going to care about you. We clearly care about you at this place. This is a sacred place, right? It's a safe space. You're supported. You know, I just want you to know these things. So just take a deep breath. If you feel that anxiety, take a breath, take a pause. Know that you're supported. If you need help, just ask. You see what I'm saying? And you have a little bit of time right now. So time is on your side right now. Just move at a steady pace. I encourage you to get ahead. This is designed for you to actually learn on your own because we don't have a lot of time together. Okay, guys? And again, on that note, we're going to end the session here from one beautiful mind to another. Enjoy the rest of your day, guys. Take care. Peace. You guys want to ask any questions? Going once, going twice.
Professor,
Yes.
for 1.3, there was one homework. I think it was question 8 that I was kind of confused on.
Okay. So as you make your way through the homework, it is a good idea to click on the Ask My Instructor. What that does, it sends me a screenshot of your very question. And all I do is pull it up on my device like this. I load it to my tablet and I make video responses, right? Because if I pull it up on my own, if I do it like I'm doing it now, it's not going to have your numbers. But if you want it to have your numbers, you make use of the Ask My Instructor right here. And, you know, we can work on your specific question. Is this the right one with this cost function?
Yes.
And I know yours is more than likely have different numbers. It says, suppose that a fashion company determines that the cost in dollars of producing X cell phone cases is given by this cost function. Find the average rate of change and interpret the significance of the results in the company, right? So this is basically telling us the slope as we go from the cost of producing 300 phone cases to the 301st, right? So this is telling us how much more it's going to cost to produce one more unit above 300 cases, right? So with this form, all you do is we're plugging in 301 into the cost function, we get an answer. We plug in 300 into the cost function, we get an answer. We say the first answer minus the second answer divided by 1, because 301 divided minus 300 is 1, right? So I have it, where is it? This guy? It's here. Yes. That'll work. All right, you should be able to see this. Okay, so what I'm going to do, I'm going to put in my cost function here into my y equals. We got this negative 0.05 x squared, okay, plus 50x, okay. So then again, I just want to calculate when x is 301, I get an answer. When x is 300, I get an answer, and then subtract those two results, okay. So what I'm going to do on the right-hand side, there's the button, there's the clear button. This is a TI-83 Plus that I'm using here. To the left of the clear button is a button that says VARS. It stands for variables. At least that's what it means to me. So I'm going to click on that button that says variables. I'm going to go to the right to go to Y variables. I'm going to click on number 1 for function and number 1 again for Y1. What I'm doing is calling on that function I just typed in. All right, let me make sure I have it typed correctly. Yes, it looks good. All right. So I'm calling on that function. Let me do that one more time. So to the left of the clear button is a button that says VARS. I'm going to click on that. It stands for variables. I'm going to go to the right to go to Y variables. I'm going to click on number 1 for function and number 1 again to call in that function that I just typed in. I'm going to do an open parentheses. So now, let's see. When X is 301, the corresponding Y is that 10,519.95, right? I'm gonna just hit second enter to call on that function again, but instead of doing 301, I'm gonna do 300, right? So 10,500. So then you can see that the difference is 1995, all right? So if we put that 10,519 over the 10,500, minus the 10,500 over 1, the result we get is 1995. So basically about $20 more to produce an additional cell phone case after the 300th case, right? It costs us like $20 more, $19.95. Now, see, that's important, right? Because if we have this business, we see that, it's like, okay, well, how much more will it cost us to produce one more cell phone case over 300? Oh, it's $20. So if I know it cost me $20, now I want to be like, okay, I want to maximize my profit. I know I'm not going to sell it for less than $20 or whatever, you're trying to turn a profit. If you sell it for less, you're going to be in the red or whatever, right? Let's see if that's correct, right? That one was good. We can do another one. We can do, oh wait, we're not done. Yeah, this represents the additional cost to produce one item after the fixed costs have been paid. It represents the average cost. No, additional cost to produce one more item after making 300 items. Yeah. So after we produce 300, it costs us basically $20 to produce one item after the fixed costs. No, one more item. Yeah, let's go with D. That's the one I'm leaning towards. Okay, that was good.
Wait, Professor, how'd you get 19.95?
So all I did, I took the cost function, I plugged in 301, I got an answer. That's where that, let's see, where'd it go? This one. So when X was 301, we got a result of the 10,519.95. When X was 300, we got a result of 10,500. So you say that first answer minus the second answer divided by 301 minus 300. And that's where the 1995 came from. These are good questions. Why is it still there? Okay, thank you. So then, with yours would be different, different numbers, but the same concept. Let me see who we got hanging out here. Okay, we got some people. That's cool. I know it's intense. Power rule? Yes, that's the shortcut, right? That's what's coming up. I wasn't ready to talk about that. Difference question. I know that intimidates students. But if you realize that it's just the slope between 2 points and take it part by part, don't try to do the whole thing because you'll be overwhelmed. Just do f of x plus h first. Then whatever answer you get, say minus f of x. Being sure to distribute your negative. And then whatever answer you get there, hopefully you should be able to factor out an h and divide by h and then cancel. And then take the limit as h goes to 0, right? That to me is easier when you break it apart. Do it part by part. Were there any others that you guys like to talk about? And I will also say, if you want me to do yours specifically, you can use the Ask My Instructor now and I can pull it up and we can do yours. Instead of me just doing random ones, we can actually work on yours specifically. Oh, I know how that goes. Any other takers? And you don't have to do your video. We're not really doing that. Okay. You guys want to do any more? Going once, going twice. I think I made a copy of this available. Did I do this one? I think so. Yeah.
Professor.
Hmm.
Do we go to Blackboard to subscribe to your YouTube channel?
Yeah, you can. Yeah, if we go to Blackboard, I didn't want to show our stuff. Let's go home. So when you log in, it'll look like this. You open up the main folder, and at the bottom, the YouTube is there. It should take you directly into like a playlist of the old recordings. And I try to update it with the current ones as well. Okay. So I'm gonna, if there aren't any burning questions, I'm gonna go ahead and stop this stream. But as you work, if you want my input, I know my energy is jarring. It can be, it's nothing I can do about it other than just make myself available. If you do want my input, make use of the Ask My Instructor, right? And I'll basically load your specific question to my device at my earliest convenience, right? If I see it and I can sit down and create the video, I'll do it as soon as I can. But yeah, you can use the Ask My Instructor, and we can keep going with it. Otherwise, we're going to go ahead and end the session here. And from one beautiful mind to another, enjoy your evening, guys. Okay, take care. Any other questions? Going once, going twice. Forever hold your peace and rights. Okay, guys, go ahead.
Did you get my name on the attendance?
And this, what's your last name?
Ogboy.
Okay, let me see. Let me pull it up. I know there's a way for me to do it without showing it. I think I can do it here. Hopefully this works. This one. I think it's working. It looks like it is. What's your last name again?
OGBOI. Starts with
Yeah,
O.
yeah.
You got me?
Yes.
Okay.
So I take attendance as I let you guys into my Zoom. You got credit. Yeah, yeah. Okay, guys. So we'll go ahead and stop there again. If you need me, then just use the Ask My Instructor. It totally showed, so that didn't work, but that's okay. We're going to go ahead and end the session here. And from one beautiful mind to another, take care, guys.
Professor,
Yes.
when we just ask your instructor, do we have to go to the Zoom link? Or is it going to just email the problem to you?
It's just going to email the problem to me. I mean, and like, you can log into my Zoom at random hours. I get those notifications. Sometimes I check them, sometimes I don't. So like, if you're trying to reach me, you can log into Zoom and just wait like maybe 5 minutes. If I don't show up within 5 minutes, then I probably won't show up. But sometimes if I see a student log into Zoom, sometimes I'll like try to get on like, hey, are you okay? Did you need help with anything, or did you have questions? But with the Ask My Instructor, it'll just email me a screenshot, and I'll just make a video response. It's not necessarily going to be live, but it'll be a video response, and I'll send you the link to the video response. Yeah.
Okay.
And so like, for instance, I did one video response this morning. If you had your notifications, like basically the suggestion is to turn on your notifications. So as I do these posts, you can at least see the title. I try to do a relevant title. It was like, oh, I had that same question, and then I'll check it. I was like, oh no, that's not me. Then you just ignore it or whatever. Okay, guys. All right. Once, going twice. All right. So we'll try again. So today was what, Monday? We did 2 sections. The goal is we honestly need to do 2 sections on Wednesday as well. Now I want to say once we get caught up, then we might be able to have time to kind of start going through some homework, right? But we got to get caught up a little bit. So the time that we normally would spend on homework in class, we kind of have to work on the next section until we get caught up. Okay. All right, guys. Enjoy your evening. Until next time.
All right, bye.
Take care.